So welcome back. Today is Tuesday, the 24th of October. This is CSC239 Scientific Computing Applications, and today we're going to review some specifics of our fourth module in Blackboard. Essentially, inside the references folder is the completed version of our updated module for study guide. There is also some quick notes, a reference on descriptive statistical methods, and then a YouTube that we'd like you to watch before you perform the box and whisker plot portion of the descriptive statistics assignment. So specifically in our module, can everyone see this screen? Hello, Anwar, how are you?
I'm good.
It's good to hear. We're basically going to pick up with macros and pivot tables, and then begin our review of the two kinds of input data used for statistical analysis, and then begin some quick essentials for the most common descriptive statistical methods. That's what we'll be doing today. Our three assignments. So this is one module where we do not have a full-blown solution, but we have three assignments: a 2-point assignment utilizing macros and pivot tables, and then a 3-point assignment for descriptive statistic methods, and a 3-point assignment for inferential statistic methods. Okay. Any questions about what we've just reviewed here?
No.
Let's see. For the 4.1 assignment, you watch the YouTube video and perform the same tasks by following the steps shown using your own Microsoft Office applications. You post both screenshots, the ones that are shown in the YouTube video, with your own name clearly shown. So you'd say like 4.1 T Kentop part 1A, part 1B, because there are two screenshots that are needed for part 1. Same is true of part 2. So each of those screenshots are worth a half a point. You're creating a simple data table in Excel, like the one I'll show you in a few moments. You'll have no spaces between the 6 column headers and the 10-row data entry. And then you'll create a simple pivot table that utilizes 4 of the fields and changes the defaults. We want you to use a suitable function in one case, and then to simplify the data that's displayed so it's easy to understand. So you'll take a screenshot of the original data table and a screenshot of the pivot table once it's complete. So it's pretty self-explanatory. One thing we want to emphasize in this module, we spoke about the scientific method. In our last session, we reviewed the basics about the scientific method. And an important focus for this course is to promote and preserve the capacity to identify and verify important patterns in experimental data. So this is where the magic happens. When we discover things upon investigation, if we're meticulous in the way that we go about our study, and that's what the scientific method was all about in our last session, then we can generate statistical data, and that leads to discernible patterns about the trends in the data, the relationships of the variables, right? So in data sets, we have things that change and things that don't change. We'll talk about that more in a minute. And so this time the focus swings back to quantitative analysis, where in our last module we were dealing with databases. We're diving deeper in the world of numbers. The important thing to understand is that you have to be able to repeat or duplicate results when you share outcomes of your scientific investigation. If your data processing and statistical analysis are sound, then you can share your outcomes with peers who then review and work their own experiments. They work their own investigations. And if they can validate and repeat, that's where the magic happens. That's where discoveries are made. And people publish, oh, hey, there's a relationship between this attribute of a data set and that attribute of a data set. Who knew that there was a relationship between the Scandinavian cultures and this particular health statistic, right? So that's just one example of what we're talking about. Now, they may not have the same, others who try to repeat the experiment may not have the same environment or resources, but that's half the magic too. Especially if they don't have the same environment or resources. If they repeat the same method and then can validate similar results or analogous results, maybe not exactly the same outcomes, but the same pattern, right? The same relationship. That's equally of value. So we did mention that there are two common flavors of numerical data analysis: descriptive, that's more numbers oriented, and then inferential statistics, which have more to do with the trends in the numbers, right? The probability of, or hypothetical probability that there are data elements in a set that are related or completely unrelated. So our study guide is going to be broken down into 4 sections. So in the first section, we talked about already how you can conduct and repeat a method, a scientific method of investigation. And now we'll be talking about our capacity to work with data, to process data consistently. And when we talk about processing data, right? So we talk about processing data. So this is consistent with what we covered last session, right? This is what you're seeing here. Should ring a bell, yeah. So our ability to process data, when we talk about processing data, right? Data processing, what we mean by data processing is that we're talking about organizing and structuring the design of data sets. But we're also talking about the entry, analysis, and interpretation of data elements in those sets, okay? So each data set is composed of related data elements. To the extent that we can organize or structure those into the smallest common arrangement, right? That has to do with database normalization from our last module. But we'll be investigating another way to organize and structure data in a very practical manner. And then after we're talking about the data sets themselves, we want to pivot and talk about how to consistently process the data when we're dealing with entry, analysis, or interpretation of those data elements, right? So the first thing, does everybody know what we mean by SCA? I've used that acronym before. I just want to make sure that it sticks.
You can tell us again.
Scientific computing applications. So when we're talking about database applications, Microsoft Office Excel and Microsoft Office Access would be two applications that we can use for scientific investigations in terms of database and relational database creation and management for Access, and for numbers, statistical numbers analysis, Microsoft Excel. So just remember, when we talk about SCAs, we're talking about scientific computing applications. It's the name of the course, right? So quick and easy automation features such as macros. Now, one of the things about macros is that you can extend those macros and develop them further with built-in APIs, application programming interfaces. So macros record the exact keystroke and mouse clicks by object and position. So when we're talking about object and position, that has to do with mouse clicks, right? Performed by a user. We have demonstrated a macro once before in this class, have we not?
What did you say?
We have demonstrated macros in this course before, correct?
I believe so.
Yeah. So does anyone remember what we did to access that feature? One thing that we called out was that it's not present on some Excel screens. So this is a review of previous module content. 3 important considerations for efficient use of macros. To utilize the macro feature, you have to often enable the Automate or Developer ribbon using the Customize ribbon. That's a feature inside Options in the Office application file menu. So I'm going to show that to you. What I'd like to do is I'll create a whole new spreadsheet, and I'll make that bigger. And we'll save this as my first macro, okay? On assignments, my first macro. And I'll use my first initial and last name because that's one thing you can do. All right, so in order to view this option, many users in Excel do not see the Automate or Developer menu option. And when you click each menu option, an entirely different ribbon appears. So Automate is the one menu that you find for macros. But macros don't exist exclusively in Excel. You can actually use macros to automate form letters. Does anyone know what a form letter is? No? Never heard of the term form letter? If you have a customer database and then you have a template letter, it's a form letter, a template letter, and there are space holders for the database fields for first name and last name and address and You can rapidly generate thousands of customer letters that are basically custom crafted for each person, right? Shows their particulars, their balances, their information, right? Let's look at Microsoft Word as an example. So if we open up Word, you see the developer menu here, and recording a macro option is shown in the developer. I don't think there's an automation or automating menu. If I look under options here, so I go to File and then Options and then Customize Ribbon. If we take off Developer and collapse that, I don't see an automation menu. So it's a little different for each one, but you do have a macro option in Word. And that can be very, very helpful, especially if you process data using Word or Notepad. That's actually some pretty cool tricks there. So if I select developer, then I get to see it here. In Excel, let's check Access. I think we looked at this in Access. If I open up a blank database, then I go to Create. I think it was actually in the Create menu down here under Create a Macro. So instead of having a separate ribbon for, let's see if there's a separate ribbon for developer. There is no separate ribbon for developer and Access, but that's because a lot of the development features and functionality are already built into the database tools and creation ribbon where you can create database objects. So just remember, in Access, you find the macro in the create menu. It used to be in older versions of Access. If you have an older version of Microsoft Office, there is a developer's menu or other menus for that. So if we want to automate something, all we have to do is record our actions. And if we record the actions, now it's basically going to record what I do. The problem with mouse clicks is that if you use a mouse and you're using different screen displays and you're selecting different objects, as the macro records, if you move to a different screen with a different display resolution, or if you start off at a different cell, then the recorded mouse clicks and actions for the mouse can misfire because they're starting off in the wrong place. So just remember, whenever you're depending on mouse clicks for your automation, it has to be consistent, and you have to have some kind of prompt for the users so that they know, okay, before I use this macro, select cell A1, right? Any questions about this? So while I'm recording, it's picking up all the different things that I'm doing. And I can format, I can center, I'll put Can everybody see what I'm doing here?
Yes.
So let's see, Saudi Arabia, 1 inch per year, maybe. 114. So now I'm going to save this. So I should be able to save the macro, right? I'll go ahead and think I'm in the cloud. That's what's going on here. When I go into here, oh no, yeah, this is in the cloud. I want to pick another place here. Just say test. So what I can do is open up a new spreadsheet, select A1, and then I can run this thing and it'll repeat everything I've been doing. Now this interface and how it's laid out and how it works is different from what we were doing last year. Did everybody see what just happened right here?
Yes.
That was pretty fast, wasn't it? I mean, all I did was click and then boom. Let's do that again. So I've selected A1 and I run it. Instant. The important thing to remember is that the way that you work with data and the way that you enter specific pieces of information, oftentimes there's repetition or a consistent format that you have to observe. And one of the easiest ways to perform that task without driving yourself bonkers, because it's just repetitive otherwise, is to create the macro. And then, of course, because it's a script, you can use it in other spreadsheets, as long as you have that script. So we've already mentioned about the mouse clicks. If they're replayed from a different starting position, you get a different result. And that could cause disaster. Well, if what you're repeating is simple, like in this case, it's probably not going to cause a huge problem. If I start on D6, let's see what happens if I run it with D6. It may just go ahead and populate right here instead of over here. Or it may throw a lung. What do you think? Is it going to work the same and do this? Or is it going to barf up because I'm starting in a different place?
I don't think it's gonna barf up.
Okay. All right, let's see what happens. Remember that when we started the macro, what was the first thing I did with the mouse? Always. I clicked into the empty A1 cell. Does everybody remember that?
Yes.
Okay. So that's just something that you want to be aware of in terms of if you build in the mouse click as a part of your macro, you won't have a problem. But if you build a macro for a complicated set of data elements, and then you're clicking into a different arrangement, it's going to repeat everything. And if there are different values in there, it can basically mess up. Now, one of the cool things about macros from the developer menu is that from within the developer menu, you can take a macro and you can convert it into a Visual Basic module. So Visual Basic is one of the programming languages in Visual Studio. Has anyone ever heard of Visual Studio?
No, I haven't.
You hadn't heard about Visual Studio? Okay. Well, in here, has anyone else heard of Visual Studio?
No.
Really? Okay. This might be worth doing then. So inside, no, not here. Inside your campus portal, if we scroll down, there's an option called Azure for Education. Office 365 is here, of course, but Azure for Education is actually a really cool place. You'll sign in using your 900 number. So I'm going to use my email address first, and then it'll prompt for my 900 number. So I'm going to use my UVI email address. When you use your UVI email address, remember to include students, yeah? So at this point, it's asking me to enter my password. So inside Microsoft Azure Education, there is free software. There's a full-blown database server that you can install. You have access to Windows, but it's the server edition instead of the desktop edition. Server 2022 Standard Edition works just like Windows. You can create a virtual machine, and in here, Visual Studio 2019 for the Mac, and then there's Visual Studio Community Edition 2019, right? So Microsoft has a programming language they use quite a bit in here called C#. Has anyone ever heard of C#?
I've heard
No.
of C plus.
You've heard of C+. How about Java? Has anybody heard of Java?
Yes.
Yeah.
So Java uses a runtime, yeah? It's not interpreted like Python, but it uses a virtual machine. And C# is like Java in that respect. It's a bit like Java that way. And the more important thing is there's also a programming language called BASIC and Visual Basic. It's been around a long time. The thing that I want to cue you into is that you can convert a macro into a Visual Basic module that's used to create add-ins. And add-ins are basically graphical objects that you can import and install into the ribbon of other application Office suites, right? So all of your colleagues, you could create some automation and then create an add-in, and then everybody could go to the file options and then go to add-ins, and that would, you could build an entire ribbon of features and functionality. You could essentially automate all of your data processing, all of your workflow. And so workflow automation is a huge thing, and that's an important aspect of data processing. When you automate workflow and the steps that you go through to create the digital information that you're working with, you have better results. That's just part of it, okay? So you can create graphical automation components called add-ins that can be ported into and used on other systems. Basically, you're building your own graphical apps, right? You have your own user interface that you can extend with the regular Office application suite and build whole ribbons with add-ins. Any questions about macros?
No.
Well, let's pivot. I'm sorry, I couldn't help that. Let's pivot the focus of this class to talk about pivot tables. When we talk about pivot tables, what we're talking about doing is taking an Excel spreadsheet that's created like a flat database. So if we have, let's pretend that we're using Excel instead of Access, because we like using Excel. We're just familiar with it. And the whole Access thing is sort of strange and foreign to us. And this is just a quick and easy way of organizing information. So we create what's called a flat database. A flat database is a single data table. That's all it is. So a flat database is a single data table that's constructed using a sheet within a spreadsheet application, okay? So even though we're in a spreadsheet and the intent is to use numbers, we're adding additional information to all of the numbers that we have in the spreadsheet. And this is probably simpler and easier to organize and work with than creating a full-blown relational database, right? So, I mean, you can see the charm here. So if we have information here, and I have name, age, sex, salary, transportation mode, and communication preference. Let's say that I have a simple data table with member statistics. Is everybody following what I'm saying here?
Yes.
All right. And you do know that you can basically take a column and you can sort it, right? So you can filter it and sort it A to Z, right? But guess what happens if I use this function and I have labels in the first row that have nothing to do with the data elements, right? So what am I saying? I'm using the first row and set of columns to define the data set or data table. And that first row isn't actually the data itself, it's a label or identifier for that data. Okay? So what happens if I try to sort from greatest to least salary here? What happens? Is it going to change the name based on sorting?
You should, right?
It should if I expand the selection. So when I try to sort by this column, it's going to want to expand the selection. What it means is, okay, when you sort this salary, you have to select the other fields, the other columns, or if you don't, you'll get out of joint, right? If I select this and click filter from greatest least to greatest, what'll happen is this will change, but then these values will stay in the same place. And the age will stay in the same place. By accepting the default, I do this. So it used to be that Excel wasn't as intelligent as it is now. But you'll notice it sorts from lowest to highest. And it also changes the names and the age and the sex and the transportation mode and everything else, right? Now, depending on the data set that you import into Excel, it's not that clean. Depending on the data set that you import into Excel or set up in Excel, sometimes when you click the sort and filter, you don't get a clean result like that. But in order to set up a pivot table or to organize and analyze your data quickly and efficiently, right? That's the goal. The first step is to set up your data table in a sensible manner. So you want no space between the columns. That's one of the things you have to remember, is that you're going to create your data table with no spaces between the columns. For your assignment, you're going to do the same thing. For your assignment, you're going to create your own data table, and you can't use this one. You have to create your own, and it has to be 10 records long, in addition to the lead record, which includes the headers of the columns, okay? So what am I saying? You're not just going from 2 to 10, because that's only 9 records. You're going from 2 to 10. I want you to build your own with 6 column names and 10 records. Everybody got that? It's for your assignment. And this is an example. Now, I want this to go back. I want this to go back the way it was. What's a simple thing I can do to make it go back before the filter was applied from A to Z, from lowest to highest salary? What simple feature can I engage to put this spreadsheet back the way it was when I started?
You could undo or go to the sort.
Oh yeah, you could undo it. Yeah. Now, let's pretend that I want to keep this, but then I want to go back, right? Can I do that? What we're hinting at here is something called progress by revision. Here's a pivot table example. That's the name of this file, right? And previously, this is how it looked. Yeah. Actually, I'm going to take this pivot table and I'm going to delete it. I'm going to delete this whole thing because I want to create a new one. So you know what a new one looks like and works like, okay? So I changed the name of sheet 1 to member stats, and this is what I did, okay? Everybody with me so far?
Yes.
I'm going to save as version 1. Now, this isn't something that's in your study guide, but it's going to be in the addendum. We will have an addendum to the study guide for module 4, and the addendum will talk about progress by revision. So this is version 1 or revision 1. That's the example, right? And then I'm going to highlight this again, and I'm going to sort from smallest to largest, right? And I'll expand the selection. Well, yeah, I'm going to expand the selection, and that Then I'm going to see if I can go back. So that expanded the selection and it modified all of the entries so that each of those records stayed the same, so that each of the entries were consistent, right? So what I'm going to do is save as what? What do I put here? Version 2. Everybody understand what I just did there?
Yes.
So if I go back into I have version 1, I have version 2. If I open up version 1, oh, I have everything back the way it was, right? As I'm making changes, in case I make a mistake, I can go back to earlier versions. That's the important thing about progress by revision. It's not something they teach in textbooks, and I'm not so sure. Well, they do. In coding, it's called version control. It's got a fancier name, okay? And the way that you do it with coding application, with programming languages, it's called version control. But when you're using commercial off-the-shelf applications like Office, that's called it's progress by revision. Okay. Any questions so far? So this is version 2, right? That's what we have here, version 2. So this time what I want to do is I want to take this same column and I want to sort from largest to smallest this time. Only this time I'm going to continue. Now, I want you to notice Xerxes, Bosworth, Smith, Johnson, Theron, Willis, right? Well, what's the problem with using this approach with your data? If you enter data for each of these in this order, what's the problem with what I just did? And by the way, I better do save as version 3, right? You see what I'm doing here?
And we're just reconnecting.
Okay. So I have version 1, version 2, and version 3. Here's version 2. Here's version 3. Up. There we go. Look what happened to the salaries, right? They flipped, right?
Yeah, it doesn't look like. Oh, wait, no, yeah, they flipped. Never mind. Yeah, you're right.
It didn't preserve the salaries, did it?
No, yeah,
It did not preserve the salaries.
it's for the wrong
And
people.
yeah, and is it the end of the world? No. I just go back to what? I go back to version 2. So if I make a mistake along the way, it's easy to back up the truck. That's the important thing I want you to understand, is that if you use progress by revision, you save yourself a lot of headache. This is one thing we ought to teach people about, use of computer technology in general, because everybody just assumes that, programmers know how to use computers the best. No, programmers know how to create programs. That doesn't mean they know how to use an application that already exists the best. And that's one of the things that life's little ironies there, right? Okay, so let's go back to version 1. All right, so just remember in the addendum, when I talk about progress by revision, all right, I'm going to assume that version 3 is barfed, okay? So I don't want the data set ruined. I want to create an authentic pivot table so I can analyze. And first of all, what is a pivot table? All right, that's probably something we ought to settle here. So a pivot table, an Excel spreadsheet or a data table is basically just a structured flat database, right? But a pivot table is a reporting and summation tool, right? So it's a tool to summarize and report on a given table. And, you know, I'm getting this from, you know, there's a lot of ways to explain what a pivot table is and what it does, but the easiest thing to do is to demonstrate it for you, I think. So creating one is very easy to do. You can just accept the defaults and then go from there. So all you're doing here is taking the data table and then inserting a pivot table and taking it from there. So in your Blackboard assignment, after you have created a simple table, right? And actually, now that I think about it, I don't want to sort by salary. I want to start with the original data the way it was entered. So I'm going to go back. See, now I have the luxury of going back to the original data. What can I do? I can troubleshoot. I can go back and see how I worked the process just by going back through the versions. So now I have the original data that was entered in order as it was received, and it wasn't sorted by salary. It wasn't organized. In life, that's how it is. We collect data of all sorts, and I don't. So somebody is calling. Hold on a second. I got to see if that was a student that was just calling. I think it's a student in his class. Everybody stand by. Okay, we're back. Can everyone see the screen?
Yes.
So,
Yeah.
so here is the original data, the way it was entered as it was received. And the truth is, when we're collecting data, we're not, if you were studying if you were studying frogs in the rainforest, all right, tree frogs in the rainforest, and you were measuring the tree frogs in the rainforest, the odds are pretty good that when you encounter each frog, you're not, if this were body weight, if you were to name each frog and then you had the body weight of each frog, the odds and the age of each frog, the odds are pretty good you wouldn't encounter in real life the oldest to the youngest frog or the smallest to the largest frog. You would get all this data in a mixed order, right? And so you need to be able to go beyond just a single column sort. And that's the value of a pivot table. So if you pick just one of the data elements in that data table, and you have your data organized where there are no spaces between the columns and the rows, and then you use the insert menu and you just click pivot table like that, it's going to create a pivot table and it's going to ask you what range do you want to use. And I want to be able to work with all this data, so I'm going to leave it there. I want to put it in a new worksheet, so it's going to create a new tab down here and I'll click OK. And now it's asking, okay, which of the fields do I want to sort by? I don't want to sort by name. I want this to be anonymous. So in a lot of data sets, we want to protect the names. We want to anonymize our data. That's another cool part about this, is that we can just select the other things, right? So let's use transportation mode and communication mode. Can everybody see what's going on here over on the right, on the left?
Yes.
Now, wouldn't it be nice if I knew the average of the females instead of the sum of the age? Like, what's the average female age and the average male age? Right? So it says sum of age. I'm going to click this, and actually, if I go down here to the lower right, if I click sum of age, and then I go into value field settings, I can pick, oh, there we go, average. Or I can pick count, how many females, how many males, right? What's the max age? What's the min age? Does everybody see what's going on here?
Yes.
So I want to click salary, sum of salary too. I want average salary, average age, average salary. So I'm going to select value field and I'm going to use average here. So now the average is this. I can go ahead and format this. So I can go here and make this dollars, right? And this dollars. And I can select this and decrease the number of decimal points just to make it easier, right? So the average age of the males is 34. The average age of the females is 37.7 years of age, right? And how many are using a limo? Well, that's giving me what I want to do is sum the limo, right? So transportation mode, I want to sum that. Sum. That's not quite what I want. I'll hit the back button. You get the point. I can take this value for average of age and average of salary, and I can change it so that it's sum or average. So this is just to get you started so you get to see the power of the thing, right? I'm gonna run this down here. You have a lot of flexibility to include or exclude information, and then you can work quick statistical functions so that you can adjust and then break out the data in a more understandable manner, right? So we know that the average age of the males is 34 and they make about $60,000, and the average age of the female is 37.7 and they make 83,000 according to our original data. Now, the rest of this stuff, you see here basically that in terms of limousines, when people prefer being transported by limousine, that instant messenger and voice is one of their preferred communications options, but or by car. So by limo or by car, you have more than one person that uses IM and voice. But as far as mopeds, the mopeds only use instant messaging, and the people who travel by bus only use text. So visually, it helps you break out some quick information about things that you could otherwise not see if you were looking at this. As you're looking at this, it's harder to tell what's going on based on that criteria. Now, the reason they call it pivot is you can select different criteria. So one of the things I did was I created salary as the lead, right? But I could choose to make a pivot table based on age, or a pivot table based on communication preferences. And that's going to give me it's going to render a different organization of the data. The goal here was to help you see how quick and easy it is to sort through this stuff. So are there any questions about pivot tables and how to build a quick pivot table? That's pretty much what you need to. Okay, so that's pretty much what you need to do to complete your assignment, right? You're gonna walk through the same steps that we followed for the macro, and then you're gonna build your own data table and then create a pivot table with it. You can change something to a suitable function like average or count or whatever. And just modify the way that information displays by changing the number of decimal places that are displayed. And that's all you have to do to complete the first assignment in module 4. The last thing we're going to cover today, before we end our session, is a simple review of the two kinds of input data with statistical analysis. So when you're using statistical methods, the thing to remember is that there's two basic kinds of input data. All right, discrete and continuous. So data can be classified into one of two types. So discrete data are clearly and cleanly defined into categories. The examples of this would be like Boolean values, yes or no. So if you have a simple choice, right? If you're studying motion in physics, is something at rest or is it in motion? Yeah, well, okay, relatively speaking. So don't tell me that even though a ball is at rest on a table, the table is connected to the ground and the ground is connected to the surface of the earth, and the surface of the earth is rotating at so many thousands of miles an hour as the earth rotates around the sun. So it's actually tracing a corkscrew through the, yeah, we don't want to get into that. If it's moving, okay, if it's sitting still, it's at rest, right? It's two things. The months of the year, right? We have 12 months of the year. The species of an animal, the sex of an animal, right? We're talking about in the wild. So continuous data, on the other hand, is something that usually involves decimal points. So another way to look at this is discrete data involves choices. So you're choosing one of the defined criteria that already exist. But continuous data is really data that you get from measurements, right? It's measured using a continuum of ranges or a range of values. So, and it all depends on how granular the scale is, how finely the scale of measurement is. So examples of continuous data include things like height and mass and temperature, because we can measure temperature, right? So the fact that something is a solid object, that's a state of matter. Our states of matter is that a discrete type of data, or are states of matter considered to be continuous data? First of all, what are the states of matter? Let's talk chemistry and physical science for a second. If it isn't solid, then it's something else. What else can matter exist in as a state?
Like, I don't know, water.
Yes, water, a liquid, right? Absolutely, a liquid. So it could be solid, water could be ice, water could be in liquid form. There's one other state that water can exist in. What state is that?
Gas.
A gas, right? It's called steam. So we have three discrete states of matter on planet Earth. Now, there is a fourth state of matter that exists out in space. It's called plasma. Well, and it also exists in some places on Earth, right? So there's a fourth state of matter called plasma. We're not worried about plasma, but technically speaking, matter could exist in a state of plasma. So there could be a fourth state of matter. If there's only four discrete states of matter, and your goal is to indicate or select which it is, are we dealing with discrete data or continuous data?
It would be continuous.
Well, if we measure the temperature of the water, then that would be continuous. But if we're noting that the water is solid and it's ice, then that would be
Discrete.
discrete. Or if we say the state of matter is liquid, right? So if we say a solid object at room temperature is 78.3 degrees, the state of the matter is solid. That's a discrete data element because it's only one of four special categories: solid, liquid, gas, or plasma. If we measure the temperature could be anywhere from 0 degrees, where it's ice, if we're talking about water, to 100 degrees, it's hot, it's liquid, to 250 degrees, it's steam, right? So because we're using a range of measures, that's what continuous data is. Now, it's really important to understand discrete and continuous. When you're looking at a data element, the first thing you have to decide is, am I dealing with discrete data or continuous data? We're going to learn on Thursday why that's so important, okay? But in order to understand statistical analysis, the essentials, that's the starting point. So today we reviewed specifics about data processing, right? Data processing is being able to identify and verify important patterns. And in terms of how you structure data into sets, how you organize them into sets, and then with the data elements inside those sets, right? What you're doing with them. So at the end of the day, each of those data sets have data elements, and the data elements have to be entered, analyzed, and interpreted, right? So that's what the rest of data processing is, generically speaking, okay? Any questions before we close today?
No question. No questions for me.
Thank you for joining us. Today is Tuesday, and the first assignment for Module 4 is due by the start of class on Thursday. So please be sure you finish the assignment by the start of class on Thursday. Thanks for joining us. We'll see you then.